Advanced Algebra Chapter 13, Lesson 3, and we want to introduce radian measure. Again, I'm going to use a pre-calculus video to introduce radian measure. I'll give you, towards the end there is a unit multiplier that you're going to need to use to convert degrees into radian measure and radian measure into degrees. We'll look at that in the video. The second video we'll look at measuring the arc in a circle, and then in a final video we'll look at how we can use the unit circle then and these angles to draw a reference triangle that allows us to determine the sine value and the cosine value of any angle. Pre-calculus, Chapter 4, Lesson 1, and in these next couple of chapters we're going to be working with trigonometry, which has to do with triangles if you remember from your geometry, but it also extends to circles, and we're going to be taking a closer look at those. And we need to take a look at degrees and radians and how we work with those, which we'll do first. We'll then take a look at measuring the length of an arc on a circle, and then we'll take a look at angular motion, or angular and linear motion. What's the difference between the two, and how can we convert from one type of measurement to the other. So we'll begin our discussion of degrees and radians by showing you what the problem is. And there's a problem with angular measurement, and here's the problem. When we're working with trigonometric functions, the input is the measure of the angle. The input value that you put into the function is the measure of the angle. The output that you get then is just a number. And the problem is that there is no connection between the units that you put in and the units that you get out. Meaning, you're putting in an angle measure, which if you put in angle measure is a degree unit, the number you get out is just a number. It has no connection to the degrees. The number that you get out is not a degree measurement. And so what's the connection? You should be asking, well, we're putting in measurements of angles in degrees. What's the connection with the unit that we get out? And there really is no mathematical relationship between that angle measure, which is in degrees that you put in, and then the linear measurement that has to do with the circle that you're dealing with. In other words, look at it like this. We know that there are 360 degrees in a circle, and a circle has a radius, let's say, with a length of 1. What's the relationship between the 360 degrees and the linear length 1? What's the relationship between their two? Are the degrees 360 times greater than the radius? Is that what that means? Well, if you think about it, we could have a radius 5 or a radius 12, and then you could have a radius of 360 units. And what would be the measure of the degrees? It'd still be 360. So I can change the length of the radius all I want, but the degrees stay the same, so there's no connection. And so there's a problem, and it's impossible, in fact, to answer these questions because there's no type of connection between the units. And so what we have, however, is radians. And radians is a way that we've come up with that does relate the length of the radius with the angle measure, or a way to relate those two. So let's take a look at what radians are, and then we'll kind of show you where they come from. The definition of a radian is this, that if you have a central angle, or a central angle will have a measurement of 1 radian. So radian is now a unit of measure, it's like a degree. But a measurement of 1 radian is if the 2 radii that you draw intersect this arc, and the length of this arc is the exact same length as this radius. So if this radius and this radius, which are the same because all radii are equal, and the length of this arc is the same length as this radii, then the measure of this angle that's created by those 2 radii, we're going to give it a measurement of 1 radian. So radian is a unit of measure. So that's a radius of 1. Oops, sorry for that. So if the radius of a circle and another radius of the circle intercept an arc that's the same length as the radius, then the measure of the angle that's created is 1 radian. Well, the next question would be then, well, how many radians are in a circle then? We know there's 360 degrees in a circle, but how many radians? This is obviously not going to get 360 angles like this big in one circle, so how many are there? So let's take a look at that and apply this definition and see if we can't come up with what that answer is. So if we know that a radian is the measure of an angle that's created when the arc that's intercepted has the same length of the radius, what does that mean? So imagine taking this radius right here. And if we were to take this radius, and then if we were somehow able to bend this radius along this arc to measure, okay, and lay it on this arc, and it might come to right here, let's say, then if I drew this other radius here, then because the length of this arc is exactly one radius long, the measure of this angle right here would be called 1 radian in measure. Alright? So that's 1. And then if we took this radius right here and we put it here, and again we bent it along the arc in order to measure it, that might come to right here. So, sorry for my lines here, this would be another radian. So that would be 2 radians total. And then if you took this arc or this radius right here again and laid it here and bent it around, it might come to say like right about right there. So this again would be 1 radian in measure. So far I've got 3 radians plus a little bit more in half a circle. And actually we're going to take a look at that more closely. How many degrees would there be in a half a circle? Well, a half a circle would have 180 degrees, right? How many radians are in half a circle? Well, radians, this would be 1, this would be 2, and then this would be 3 plus a little bit more. Well, this plus a little bit more actually ends up being about 0.14 blah 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 blah. So what number do you know that is 3, 0.14, and then it keeps going on forever? What number is that? Well, that's pi. So actually, in half a circle, 180 degrees, there are pi radians. Okay? So 180 degrees gives me pi radians, or pi radians is the same as 180 degrees. So it's a very nice unit of measure. So there'd be 3.14 radians in half a circle. Or we can use pi instead because pi means 3.14. So if there's 3.14 or pi radians in half a circle, how many radians would there be in a whole circle? Well, here's pi radians and pi radians. Pi radians plus pi radians is 2 pi. So there's actually 2 pi radians in a whole circle. So 360 degrees is 2 pi radians. Right? So this is going to be what we call a unit multiplier, which we're going to use now then to convert angles measured in degrees into radians, or radian measured angles into degrees. So we just use this unit multiplier. Meaning, so I want to know, let's say I have an angle of 45 degrees. How many radians is that? Okay? Well, we need to multiply this by something that will make the units of degrees eliminate and leave me with radians. So I'm going to use this unit multiplier, and I'm going to put 180 degrees in the denominator, because then the degrees reduce, and that's pi radians. And then I'm just going to multiply these fractions together. Or actually, I can even reduce ahead of time. So 45 goes into 180 4 times. So that's all 1. So actually, there's pi over 4 radians would be the measure of a 45 degree angle. Okay, so I can use this unit multiplier to convert from degrees to radians. Well, I can also use them then to do the other way. So if I have pi over 4 radians, how many degrees is that? Well, I'm going to use the same multiplier. This time, though, I need radians in the denominator, because the radians will then reduce. and then there's 180 degrees. So the pi reduces, so all that's 1 and 1, and 4 goes into 180 45 times, so you multiply all that together, so you get 45 degrees. So you can go from one to the other by using the same unit multiplier for both. So you're going to need to be able to convert any measure of angle into radians, and then any measure of radians into degrees. And that's going to be the first part that we're going to do with trigonometry.